Um, Here's a quick demo of the L1 regression program. So let me just plot the data again. Exactly the same data as all the previous outlier removal methods, except here we're not going to remove any outliers. We're just going to do a different kind of regression or different kind of fitting a line to the data. Instead of minimizing the mean square error, we are minimizing the mean absolute value of the error, or equivalently what's called the L1 norm, which is essentially sum of the absolute value of all the errors, right? So it turns out that you can do this efficiently using what's called linear programming. And at some point, I wrote a program that does this thing. It solves for the coefficients. The y and the x matrix are the same as before. The y matrix does include a column of ones. Oh, sorry, the x matrix does include a column of ones. And let's just run this thing. And then once we run this, it says optimal solution found. That's fine. It finds the value of the parameters, the coefficients for the straight line, which we can fit here. And the fit looks like that, right? The fit looks like it basically passes through the original trends without really worrying about all these outliers. Now, how does this method do that? What happens with mean squared error is that as the mean squared error looks like this, right? So if you say x square is a function that looks like this. So as the error becomes higher, the squared error becomes even higher, right? So because of that, when you minimize mean squared error, it's very sensitive to points that have a lot of error, because you square the error. If the error is large, the regression is affected by those points that have a large error. Whereas in L1 regression, or least absolute value error regression, what we are trying to do is minimize the absolute value of the errors, the sum of that. Absolute value looks like this, right? So for x, absolute value looks like a V-shaped curve. This one sort of doesn't penalize large errors as much. It's the error, or the cost, the thing that we're trying to minimize, goes roughly linearly with the error. So the large error values here don't make that big an effect when you're trying to do L1 regression. That's at least the basic intuition. When you square the error, you amplify the effect of the large errors. But when you don't square the error and just take the absolute value, you don't amplify the effect of these large errors. So it automatically gives you something that is really nice and close to the main trend while ignoring the outliers. Okay, so that's called L1 regression.